Let us solve the equation root 2 plus 1 to the power x plus root 2 minus 1 to the power x equal to 6. So we want to solve this equation. Let's call this to be equation 1. Observe that we have got different bases, however these bases are related by the fact that root 2 plus 1 into root 2 minus 1, that's an expression of the type a plus b into a minus b, so that's equal to a square minus b square. And root 2 square is just 2 and 1 square is 1 and 2 minus 1 is 1. So we can write root 2 minus 1 is 1 by root 2 plus 1. So we can write equation 1 is, so in equation 1 we got root 2 plus 1 to the power x, we copy as it is, root 2 minus 1 to the power x. Instead of root 2 minus 1 we write 1 by root 2 plus 1 to the power x as it is. Now we got the same base, root 2 plus 1 to the power x and 1 by root 2 plus 1 to the power x. Let root 2 plus 1 to the power x be equal to u. So that will just simplify the given expression. So we can write given expression as u plus 1 by u equal to 6. Let us further simplify it. We can multiply by u throughout to obtain u square plus 1 equal to 6u. Further, we can take 6u to the left hand side to obtain u square minus 6u plus 1 equal to 0. Now this is a quadratic equation. There are many methods of solving it. Let's solve it by completing the square method. So we got, let's write the equation once again. U square minus 6u, that can be written as 2 into u into 3. So let's write plus 3 square, but I have to maintain the equality, so I have to write minus 3 square. Alright, plus 3 square and minus 3 square will get cancelled, so we are writing as it is. Just we are adding and subtracting 9 to the left hand side, and then we can write this expression as u minus 3 whole thing square. U minus 3 whole thing square. What about this one? 1 minus 9, that's minus 8, and if we take it to the right hand side it will be plus 8. Therefore u minus 3 equal to, when we take root to both sides, plus minus root 8, that's equal to plus minus 2 times root 2. From there we conclude that u equal to, if I add 3 to both sides, 3 plus 2 root 2, comma 3 minus 2 root 2. But what exactly is u? We are assuming u to be equal to root 2 plus 1 to the power x. That implies root 2 plus 1 whole thing to the power x equal to 3 plus 2 root 2 or 3 minus 2 root 2. Let's look at the case 1. So we want to solve this equation root 2 plus 1 to the power x equal to 3 plus 2 root 2. Let's regard it to be case 1. This one will do it separately in case 2. When we have root 2 plus 1 to the power x, definitely x cannot be equal to 1. But what about 2? Root 2 plus 1 whole thing square, that's equal to root 2 square plus 1 square plus 2 root 2. Root 2 square is 2, 2 plus 1 is 3. Oh yes, 3 plus 2 root 2. Therefore we can say that root 2 plus 1 to the power x is exactly equal to root 2 plus 1 whole thing square. That implies x equal to 2. Okay, what about the other case? So the second case we have root 2 plus 1 to the power x equal to 3 minus 2 root 2. Let's look at the initial work we have done. Root 2 minus 1 is 1 by root 2 plus 1. In other words, root 2 plus 1 is 1 by root 2 minus 1. So we can replace root 2 plus 1 is 1 by root 2 minus 1 to the power x as it is, equal to 3 minus 2 root 2. That can be written as, by law of indices, root 2 minus 1 to the power x minus x equal to 3 minus 2 root 2. Now again, if we square it, then we get it the same expression as we have square root 2 plus 1 whole thing square. We got root 2 square plus 1 square plus 2 root 2. If we do root 2 minus 1 whole thing square, again you will get root 2 square plus 1 square minus 2 root 2. So we'll get 3 minus 2 root 2. So from here we can say that root 2 minus 1 to the power minus x is actually root 2 minus 1 whole thing square. So definitely x equal to minus 2. Therefore final solution is x equal to 2, that's by case 1, and x equal to minus 2 by case 2, and we are done.